Hi again. So last time I already talked about what charge is and how we can calculate the net charge of an object. Now I want to introduce you to a force that exists if there are two or more charged objects in the space. This force is called electric force. But before we go there, I want to make sure that you know what force is. So suppose that you have a ball on the floor. Then you give a push on the ball or just pull it so the ball moves. So that push or pull is what actually we call force. Now, if there are two or more charged objects in a space, we don't need to give those objects a push or a pull. They automatically will exert force on each other. We usually say that they can attract each other or they can repel each other. So in physics, we don't just want to know if there are two charged objects that will attract or repel each other. We really want to know how strong they attract or repel each other. That's our goal. So if there are two charged objects with distance r apart, object 2 will exert a force on object 1 and object 1 will also exert a force on object 2. The magnitude of the force exerted by object 1 on object 2 can be calculated as K times the magnitude of Q1 times the magnitude of Q2 divided by R squared, with Q1 and Q2 are the charges of the objects and K is a constant with value 8.99 times 10 to the 9 Newton meter square over Coulomb square. So for the direction of the force, we need to know that unlikely charged object means one is positive and one is negative. They will attract each other, so the direction of the force will be towards each other. The likely charged object, like both positive, they will repel each other, so the direction of the force will be away from each other. The same thing will happen if both objects are negative. They will also repel each other. According to the formula, the force exerted by object 1 on 2 is this, and the force exerted by object 2 on 1 is this. If I write F1 on 2 as K times magnitude of Q1 times magnitude of Q2 divided by R squared, and we know that multiplication can commute, which means we can change the order, then I can also write this formula as K multiplied by the magnitude of Q2 times the magnitude of Q1 divided by R squared. And this actually is F2 on 1. So the magnitude of the force exerted by object 1 on 2 is equal to the magnitude of the force exerted by object 2 on 1. However, they are opposite in direction. So now we know that the force exerted by object 1 on object 2 equals to the force exerted by object 2 on object 1, and this equals to K times the magnitude of Q1 times the magnitude of Q2 divided by R squared. And also, we know that unlikely charged objects will attract each other and likely charged objects they will repel each other. So that's about electric force. Next time, we are going to work on some problems about electric force. Thank you. See you later.